context of this presentation is a joke or rock is a joke?
Well, the one thing, if you've been living under a rock, if you haven't been living under a rock, it was a joke.
Yes, yes.
But that's also a good point, too. Level 3s and 4s, they don't actually have to perform a rock, they just do a self-assessment, check it off. The difference between the different levels is level 1s and 2s are based off of your transaction volume. So those are the ones that are like Walmart's, etc. They actually process the most amount of transactions. So it's not actually the amount of money, it's actually the amount of credit cards they actually process through your systems. So, then there's even more stuff. There's over 220 some controls within the PCI DSS.
Yay!
So, that's a lot of work. Actually, PCI kind of recognized this, especially for people that are, whoa, pretty little hot. All right. Especially for ones that are like a level 3 or 4, they may not have to do that. Maybe they don't really do a lot of the same things that like a level 1 would. They may not have an e-commerce site, they may not have all the internal processes that they would have from a mom and pop shop. So they actually did this different thing called like the SAQ A, B, C, CBT, and D. So what it is, depending on how you're actually processing your credit card information, whether you're processing it through maybe just like a card swipe machine, or if you're actually processing it through an e-commerce site, or internally at like a retail environment where you have a bunch of stores, so you all have to process and batch stuff. Those are all the different types of SAQs. And so the same thing for a ROC too. If there's controls that don't apply, you can significantly reduce your scope based off of what you have to do. So instead of having to do all 220 some controls, you may only have to do 20 or 40, depending on which one you are. So A is the least amount of controls you have to do from an SAQ perspective. D is the most you have to do. So getting a little bit more focused in, so that's the higher level. This is sort of more focused on what we're talking about. And this is about e-commerce sites. So this is essentially the control from PCI standard itself. So you can do one of two things. You can either do a code review, or you can actually or actually just install a web application firewall. So when you have an external facing, so this is something that's available to the internet, like e-commerce site or web application that processes, stores, or transmits cardholder data, that would be what's in scope. You have to perform one or two of these types of assessments. So what's the intent of the control? Well, let's try to prevent malicious input getting into your web application. That's essentially what it's supposed to try to prevent. There's also a list of controls within one of the prior controls called 6.5, which tells you all the different vulnerabilities to try to prevent actually talk through. Injection flaws, buffer overflows, insecure cryptographic storage, etc. Those are all the things that they're trying to prevent. A lot of these things are the same things that are in OWASP. And additionally, they recognize other type of industry standards such as SANS Top 25 and also CERT standard as well. It also provides an additional layer that ASV scans or vulnerability scanning may not actually protect you from, or penetration testing. Another reason why many of the controls within the PCI DSS were actually created was because something happened, something got breached. So a lot of the wireless controls, that's TJ Maxx. Heartland actually was a SQL injection attack. However, the interesting part about it is SQL injection attack didn't happen within their PCI environment. The SQL injection attack happened outside their PCI environment. They were able to get into the PCI environment by hacking that lower security system. So how can a company comply with requirement 6.6? So there's different, there's two general things you can do. You can perform some sort of code review, and this is what they define as code reviews, and then you can also do a WAF. So what they consider code reviews is one of the following. Either a manual review of the source code, you can also do some sort of more scan-based static code analysis tool for like an actual code review, or you can also do web application vulnerability assessments. So you can either do a more manual one where you're actually inputting information in, or you can use some sort of scanning tool like AppScan, etc. So here's a big long list of a bunch of different requirements that a WAF has to have in place. So all this guidance came from information supplement from the PCI Council themselves. It was originally based off of PCI 1.2.1. We're currently on 2.0. So it has to make sure it meets all the PCI DSS requirements, reacts appropriately to vulnerabilities, so it's either going to alert you, block something, or allow something to go through. It has to make sure it meets the OWASP top 10 or requirements identified within 6.5, etc. So there's all sorts of kind of things it has to do. It has to support SSL encryption correctly, inspect web service managed messages, etc.
That sounds a lot like DPAC inspection.
Kind of, but
I mean, a little more specialized.
right. It's basically about the input and output of a lot of the web application services and protocols. So HTML, XML, etc. So making sure that whenever something goes in, it's not meant to try to put some sort of junk garbage in and try to attack the system or try to do some sort of SQL portal. So here's some additional recommendations or capabilities that may be considered within different environments. So here's the funny thing about PCI. They always give you very broad type of advice or guidance. The reason why they do that is because many organizations have many different types of environments. So one person may have e-commerce, one person may not have an external e-commerce system. One person may have to abide by other federal laws. Maybe they don't have to. Maybe they're a publicly traded company. They don't have to abide by anything other than like SOX or something along those lines. So they recommend prevention detection session of token tampering. So basically cookies or other sessions, making sure people can impersonate sessions, etc. They may also require that you have some sort of FIPS hardware key storage support. So maybe you're using some sort of HSM device to actually do encryption for your cardholder data. So those are some of the things that they recommend that you at least visit or look at when you're implementing your WAF.
I think that the one actually just before, the fail open or fail safe considerations, like it doesn't say, it has to block traffic from going through if it fails. It's like, oh, you should consider whether or not you want to allow your web application to firewall that's supposed to be protecting your e-commerce site to allow any traffic through if something goes wrong with the web application firewall. So I just thought that was kind of funny when I saw that.
The other thing is too, in some cases it may be bad if your website goes down permanently because maybe that's your only source of income. So if your site goes down, if you lose 10 minutes depending on your organization, that may be a lot of money.
All right, so now I get to talk a little bit about what I don't like about the standard. First of all, this is how PCI DSS 6.6 fails. So many scanners and web application firewalls, with the default configurations and stuff, they don't even detect these sorts of vulnerabilities that are in the OWASP top 10. I looked at a number of, or a couple of different commercial products, scanners and web application firewalls, and I've just, seen that it's not doing its job. It's not really doing what it's intended to do. The other thing is that scanners and web application firewalls do not detect logic flaws, and those are a type of vulnerability. That the web application firewall, it doesn't know that this capability shouldn't be there. And I'll actually talk about that a little bit more here. And then also, it produces a false sense of security. So you've got these developers out there that are like, yeah, that's fine. Let's just drop raw input into the SQL database here. Yeah, that works just fine. Don't worry. The web application firewall will protect us. It's kind of like, they don't even bother to try to make a decent product because they're expecting their web application firewall or their vulnerability scanners to detect all this stuff. It's like, oh, okay, I'm not going to worry about security. Let's run the scanner. I fixed those 10 issues. Now we're good to go. Let's throw this over in our environment, and we should be good. So I just think that there's some major problems with that. So what I did was I downloaded 3 commercial grade web application firewalls, and I took them and I was like, so what will it take to get cross-site scripting to to execute in the default configurations of these. So that should be noted up front. That's my disclaimer. I use the default configurations of these web application firewalls. And it literally, there was like in most of the cases, there was a little button that's like, default level of security. And I was like, yeah, I'll do that. And then it's like, you are now protected from cross-site scripting, SQL injection, directory traversal. And then there was this long list. It's like, oh, wow, I feel pretty good about myself now. I don't have to do anything else. I can just attack this thing, and the web application firewall will save the day. Yes?
So are these software layers that go on the server?
Yes, actually, these ones, I think that one actually a virtual machine that you actually had to configure to have all the traffic go through, but the other two were definitely that way. I also took a look at Barracuda. Yes? Yeah, essentially, you just put it on, in some cases it was just an extra layer that had to go through on the same web server before it actually hit the web application layer. And then in other cases, it was a proxy where it had to actually go through the web application firewall. I'm sorry, what? Oh, no. These were actually, like if a organization was trying to defend themselves or set up a web application firewall, in some cases what they could do is have it so that every time I go to connect to their web application, it's actually connecting to the IP address of the web application firewall, and then the web application firewall forwards the traffic through. And then in other instances, it was on the same server, and it was just acted as an extra layer that the traffic had to go through in order to hit the web application. Yeah, exactly. Yep. And then also I looked at Barracuda a little bit too, and I'll talk, just mention that from in one of my slides here. So now, first of all, in the default configurations, a lot of the times what I've been noticing lately is a lot of web application developers, they've been taking parameters, user-supplied parameters, and they've been dropping it into already existing JavaScript on the underlying page of the HTML or of the web application, which is interesting because all you have to do is break out of the existing JavaScript, and then you can continue to write your own JavaScript statement and make it do whatever you want to. So I thought that was actually interesting, and none of the web application firewalls protected against that form of cross-site scripting. So if you are dropping directly into the existing JavaScript on the underlying page, in every case I could just hijack the existing JavaScript. And then also some of the tags that you can use for HTML, you can actually create attributes that hold JavaScript. So a lot of times what will happen is they'll take user-supplied data and they'll drop it into a tag, and they'll be like, the name of the tag is, attack or whatever, whatever this person put in the username field or whatever. And then what they'll do is you can just put like a double quote around it, and then you can break out of the tag and then add an attribute that executes your own JavaScript there as well. So those are, I tried both of those, and the web application firewalls and default configs, it doesn't protect you against those types of things. So we're talking about the most basic form of cross-site scripting then, right? I mean, we're talking about where there's nothing else around it. You're actually inserting a tag with malicious content in it in order to get these examples to execute, which I'm going to show you. All right. So the first one I'm going to talk about was ProFence. Out-of-the-box configuration again. It said that it had learning mode enabled, which I thought was interesting, but I kept it on. I left the learning mode alone, and but I didn't try to do a whole lot. I just waited a couple minutes before it started attacking away. So maybe the learning mode would actually make this ProFence a little bit better. I'm sure if it had enough time, maybe it would. But what I thought was funny was this article on SANS where it said that that a full-featured standalone web application firewall that provides full compliance with the PCI DSS requirements. And then what else I thought was kind of funny is it said that ProFence is a software appliance, the very top of the sentence, which installs in minutes on any standalone server, converting it into a full-featured. So they're talking about that, like within minutes, you can reach this level of PCI compliance switch. So it doesn't sound like they had learning mode enabled either. All right, so what did it take for me to get this to work? So, I mean, what's good is this was blocked, right? I mean, so our most basic form, I would hope that this would be blocked, or I would probably cry. So what worked? That worked. So can you spot the change? So what did I have to? What did I do differently here in order to get this to execute? Well, that's it. I just eliminated that last greater than symbol there, and it executed. That's all I had to do. And so, you know, this great web application firewall that protects you, you know, from PCI compliant within minutes. You know, that's all it took. With the learning mode and stuff. So I was a little disappointed with this one. All right, so let's go on to the next one. Exactly. That's all it took, and that was default configuration. It's like default configuration protects you from most attacks. I'm like, yeah, let's go with that one, and yeah, that's all it took. All right, so let's talk about Dot Defender. Maybe this one was a little bit better, right? So, you know, I got this actually from their website. They said Dot Defender not only meets the application layer firewall requirements of PCI DSS 6.6, but also offers comprehensive protection against SQL injection, cross-site scripting, and scores of other application-level attacks right out of the box. So again, we're talking about right out of the box. We're not talking about after a week of configuring and whitelisting parameters. They're saying out of the box it provides this type of detection, right? So how did it hold up? All right, right here, out of the box configuration, you can see use default security profile. All right, so this one took a little bit more at least. I was a little bit glad about this. You know, give me a little bit more hope for the industry. So you can see that immediately it blocked anything with bracket script. It blocked anything immediately with bracket iframe, but it didn't block bracket div, which I was like, oh, okay, that's a starting point. That's how a lot of times when I'm attacking a web application, the idea is to look for the points to work your way up to a full attack. The idea is to find where it's weak. First of all, I had to identify a tag that it didn't block, and I found that it didn't block this div tag. So I knew that on IE, I could actually create a style attribute and give it this expression here, and that should execute in IE. So I gave that a shot, and that got blocked. So I was like, all right, so what else do I need to do in order to get this through? So I found it right here. That was not blocked. Now, we're going to take a look. Can you spot the difference? Yes. It was blocking on the word alert. Because we know that attackers always put alert in all of their payloads when using cross-site scripting attacks. I mean, duh. I mean, so all we got to do is block alert there, and we should be fine, right? No. So if you're wondering, alert just brings up a pop-up box. So, like, the attacker, what are they going to do? Hey, I'm attacking your system. Hit OK for the attack to go through. I mean, what are they thinking here? So, of course, an attacker's not going to use confirm either, but it just goes to show you that, you know, blacklisting. This is what happens when you try to blacklist keywords, which is pretty sad. So the last one here is Server Defender, and again, out of the box configuration, blocks top threats like SQL injection, cross-site scripting, and many more. And it says that's PCI compliant from birth. So I'm wondering, wow, this is a PCI compliant from birth web application firewall.
Only I can make that claim.
Yeah, he's the only person I know PCI compliant from birth. So I'm like, wow, this is going to be awesome. There's going to be all types of blocking and big alert messages and all types of stuff. So I'm like, let's go. Let's duke this one out. So as you can see, there's that default configuration there: SQL injection, cross-site scripting, directory browsing. I mean, it's not so default configurations level 3. You know, not too bad. I just left it alone. But it's supposed to block from the SQL injection and all this other fun stuff. So what happened when I attacked this PCI compliant from birth web application firewall? So that was blocked. I was disappointed. I was like, all right, round 1 goes to the web application firewall. It blocked that. But it didn't block that. Again, can you spot the difference there? again. I just eliminate the last bracket there, and it executed. And I was like, wow, for being PCI compliant from birth, I mean, that's pretty sad. All right, so web application firewalls, default configurations. We'll talk a little bit about how maybe we should lock these down a little bit more and not rely on default configurations. But how about web application scanners? Okay, so I took a look at web application scanners. They're normally pretty good at catching things like cross-site scripting. I say that tentatively. There are some web application scanners that are terrible at detecting cross-site scripting attacks, but there are some that do a decent job. But what I thought was, I was like, well, what happens if you have a web application that's designed something like this, okay? This example here. And this is a real, I've encountered situations like this before in the past in real world examples. Okay, so what you'll see here is it says that, if you are, please enter your name. All right, Bob. All right, please enter your employee ID, 001. Please enter your role, manager, okay? And as you can see here, it says, if you are a new employee, enter new user in this field. Well, if I'm an attacker, you know what I'm going to put in that field? New user. That's going to be one of my tests. I'll also try with Bob and some other stuff in that username field, but eventually I'm going to get to trying what happens when I type that new user in there, right? So with these parameters here, it just says welcome back. All right, very basic, nothing too big, right? So in web application scanners, they can't read, right? I mean, unless they can read that page, they're not going to try to type in new user. And I tried this because I tried throwing some web applications, scanners against it, and I found that they couldn't read. In fact, they were throwing all types of garbage in that field, trying to get something to execute. But
You should really get a literacy program for those guys.
Yeah. Maybe they should teach them to read. That might help. And then what happened is, so what happens if you type new user in there? Well, it responds. Do not forget your employee ID. As a reminder, you entered an employee ID of 001. All right, well, as you can see now, the only time that employee ID field is going to be reflected back to the user is if the word new user is actually put into the following field. So what did I do? Well, I took the value of 001 and I changed it to that. Parentheses, inward bracket there, semicolon, alert. I just hijacked the already existing JavaScript that was on the underlying page, and sure enough, it executes. So the example or the point of this is web application scanners. They're not always going to detect these types of vulnerabilities, and neither are in web application firewalls. They're not going to either. So what about SQL injection? All right, so this one here, this is actually a real-life demo I'm going to show you. I tried this on all the web application firewalls and their default configurations. I also tried this against the Barracuda web application firewall as well. So remember during this demo that this is actually working against a Barracuda web application firewall in the background. So this is WebPAM. It's Promise technology. It's for administering RAID controllers, and I found this page one time, SQL run JSP. And I was like, wow, that looks like it could be pretty good. So I actually created this attack here. So first what I did was I created a malicious jar file that downloads a file that I give it to download from a web server, and I create my own web server, and I put that file in the web server. Then what I did was I started the Apache server, and then I created an interpreter payload that connects back to my evil machine, and I put that on the web server too. So my jar file says download the payload from my evil web server and run it on your server, the WebPAM server. So that's essentially all those files are for. Then what I did was I started a multi-handler on my attack machine here and told it to listen for connect backs on port 443. So that's all I'm doing here. Set L port 443. Now what I'm going to do is I'm going to run a series of SQL commands in this window that's going to go download my jar file and then download my evil attack file. So right here, this just says download that wonderful jar file from that evil web server. It's like, okay, no problem. Then I had to put this annoying little call in. It made it like referenceable or something. I wasn't sure exactly what it did, but it didn't work without it. So did that one. Then what I did was I created a stored procedure that referenced the function in my malicious jar file that I had that just uploaded to the web server. So this is the create procedure. Remember, there's a Barracuda web application firewall behind this web application. Bang, okay. Then what I do is I call my wonderful stored procedure. And it goes ahead, says, sure, I'll execute that stored procedure for you. And what happens? I get a shell back. There it is. All right, so that was very, very concerning to me. And in fact, I found that the web application firewall was blocking on like 1 or 2 keywords, and I just recreated my SQL statements to eliminate those keywords, and it worked just fine. So, but as you can see, if the web application firewall is not protecting against those types of attacks, I mean, there were ticks and all types of garbage in that. I mean, I was surprised that it didn't catch any of that. So what about web application scanners? How well do they detect SQL injection? Well, most of them will actually do, a nice portion of them will actually do a pretty good job at detecting SQL injection. But this is a form of SQL injection that I have found that web application scanners, they have a very hard time detecting this type of SQL injection here. It's actually a form of SQL injection that depends on string concatenation. So what I found is in some cases, no matter what you put on the back end of a word. So suppose you have like a search field and you type in the word test and you search. You're going to get like 100 results back, right? So what happens if you put anything behind the word test? You get no response back. So if you say test, tick, colon, and then you try to comment the line out, you're still not going to get any results back for the word test. Well, in this case, what I did was I used a form of string concatenation, and I said, I actually said to go ahead and select the first character in the global name stored procedure in Oracle. So what happened was, then what I did was I iterated through the S right here, or actually, you know what? Sorry. Yeah, that's better. Okay, so then what I did was I said that when the first character of global name equals S, then return S, which is going to finish the word test. And in those cases, I should receive 100 results back from the search function, right? But I said that if it is not true, if the first character is not an S, return X. And then the word ends up being T-E-X-T, which is text. And then you'll get a different result for the word text as you would for test. So the idea is to use some sort of burp intruder or something, and then you just iterate through that S, and you can say like, A through Z, and then you look for a true statement, which is when you get the results back for tests. So I found that some web application scanners, they have a really difficult time with this form of SQL injection, but yet string concatenation and SQL injection, you can write similar queries for MS SQL and for DB2. In fact, I found this originally because of a vulnerability in DB2, and then I've used it throughout the years. So, but web application firewalls have a hard time with this type of signature. Okay, so let's talk about logic flaws. So with this logic flaw here, what happens? Well, it says, hello, you do not have administrator rights. And if you take a look in the URL, you'll see that role equals user, right? So if I'm a user, I log into the web application, and and the role that I'm logging in with is user, then it just says, hey, you don't have administrator rights. But if I'm a manager and I log into the web application, it's going to show up in the URL. It's going to say manager, and I'll have additional functionality. So What happens if you're an attacker? All you got to do is change the role user to the role manager. And that's a logic flaw. And then you'll have additional functionality. Now, you guys might think that this is a very, very basic example. But in real life, I've actually encountered these types of logic flaws before. Not necessarily this simple. But the key point is this. Is the web application firewall, this is going to look like valid traffic to the web application firewall either way, because it's going to see manager in that role parameter, it's going to see user in that role parameter from time to time. And so it's going to say, oh, this is just normal traffic. But you can see here that's a logic flaw. And web application scanners, they don't understand that. They don't understand that, oh, I changed it to manager. Oh, I see I have this additional functionality. So that's a vulnerability that web application firewalls and scanners are not going to find. So let's go ahead and now we're going to talk about the objections a little bit. Let me make sure we have some time. Is it? It's 11:34. We're good. We're good. Okay. Cool. All right. So scans, according to the PCI DSS 6.6, it doesn't say that web application scans have to be authenticated. So that's a big problem, right? I mean, so. What happens? Well, a lot of times you have these e-commerce sites, right? And it says register in order to create a user account. Now all I got to do is go, oh, okay, I'm going to register a user here, and then I'm going to log into the application, and then I'm going to try to attack the web application from the inside, right? I mean, that's how an attacker is going to think. Well, the problem is because PCI does not require or does not say it has to be an authenticated scan, that the web application scanner is going to scan the login field, and it's going to scan the username registration field, but it's not going to actually use credentials to log into the web application to try to find the vulnerabilities. So the outside could be all crispy and hard and difficult to bypass, but then you put in the initial parameters, and then you're in the web application, and it's crawling with SQL injection and cross-site scripting and all types of other vulnerabilities. So that's one of my objections to PCI DSS 6.6. Go ahead, Dave.
All right. So this is my thinking of what PCI has sort of provided and things that we need to sort of consider when using PCI compliance and how it sort of deals with some of the issues that he's talking about. So for this particular thing, currently there is no standard for code review outside of the 4 different areas that were identified, such as a manual code review, some sort of statistical analysis, static analysis of code, using some sort of scanner, or using a manual code. Essentially, you have to know what tool you're actually using and have a little bit of smarts around using that tool. So if you know that your application has some sort of authentication to it, you have to be able to see or be able to configure your tool to use authentication with it, or else you're not going to be able to find the results that you're looking for. Once again, compliance does not always equal security. You can be very much compliant within your PCI environment, but not actually secure within your environment. And also sometimes PCI has been referred to as the minimum security standard, which I pretty much agree with. An additional thing that's an issue is the scope of what you're looking at, and also the amount of resources you have within your organization, and how your e-commerce system actually works, or your web application actually works. If you're a mom and pop shop, you're not really processing credit card information, you don't have too many processes of credit card information or transactions going through that system, you may not have the ability to actually buy commercial standard tools. You may have to use something free to actually do your assessments. But once again, you really should be using a layered approach, because even within the guidance they say we recommend using a layered approach when having a WAF in place, maybe doing some sort of code review, or maybe instead of just doing one of those things that are identified within the code review, maybe doing 4 of them, or 3 of them, or 2 of them. Basically, so you catch other things.
Yeah. And this is his response, of course, and I don't agree with it necessarily, but that's but I do agree with compliance does not equal security. And the biggest problem is, I think that with this here is, I think that there needs to be a little bit more guidance. I read over the standard, and it should say something like, hey, if there is authentication in front of the e-commerce site, you have to perform, if you're going to use a scanner, you have to perform an authenticated scan. So, I mean, there's some general guidance, but it's way too broad. There's not enough information in there to really help, I think, perform a good audit, unfortunately. But that's just my opinion. Yep. And then also, PCI DSS 6.6 does not protect against the web applications, or does not protect them from these business flaws, or these flaws in the web application, right? The logic flaws I showed you earlier. So, as I talked about earlier, scanners, they just can't think like an attacker, right? I mean, I was able to read, type new user here. I'm like, hey, type new user. All right. Oh, it executed. Another thing that I've encountered is like this. It's like a delayed form of cross-site scripting. So it's like it will take a parameter on form 1, but it won't actually return the parameter until form 5. So I mean, these like delayed cross-site scripting, these other logic flaws, they're just not being detected by scanners and web application firewalls, unfortunately. So so what they're trying to do is not that effective in a lot of instances.
So, once again, at this time, code reviews only required to protect against top vulnerabilities identified through either 6.5 or one of the industry standards. Does not necessarily, maybe within like OWASP, outside of that top 10, there may be other additional things such as business law flaws, etc. But this is basically the minimum standard that you have to protect against from PCI standpoint. When PCI wrote the PCI DSS, they wrote it based on a risk-based approach. So they kind of take out the risk figuring out for you, so to speak. So when you implement these controls, it's pretty much you implement those controls or you're not compliant. And that's the way PCI works. You're either compliant or you're not compliant. If you don't meet all of them, you're not actually going to become compliant. So some of the other things is that the intent of it was to try to find additional things within your web application. That's why you're doing these types of assessments. So you should also try to perform other layered approaches within within your application. So they tried also doing penetration testing and making sure that application testing was also included within your penetration testing. So running just Nessus and then using those results and exploiting those results, in my opinion, doesn't really equate a penetration test. You should also be looking at the application layer as well. Once again, I think the best approach between all of these different things, whether it be a WAF or whether it be doing some sort of code review, you really need to strike a balance between doing automated assessments and manual assessments. Because if you don't strike that balance, there's going to be things that scanners going to miss, and it may be so many different pages that you don't have physically enough time to actually go through every page on your website. So it's really trying to strike that balance of doing manual assessments and also using automated systems or manual systems, automated systems and automated applications or systems.
And then we have here, so this objection is pretty obvious based off of my presentation here. Is the OWASP top 10 vulnerabilities a lot of times are not getting blocked by the web application firewalls, and scanners do not always detect them. So if that's the case, then is it failing? It's obviously failing the intent of PCI 6.6. So what good is it? And we can't really expect so as a PCI auditor, you can go on site and go, oh, okay, the intent is to block against cross-site scripting, SQL injection, and directory traversal, and directory browsing, and all this other stuff. But the problem is this: what happens if the auditor goes on site, takes a look at the configuration, and goes, okay, I see the default configuration blocks against cross-site scripting, SQL injection, and all this other stuff. Without somebody actually trying to bypass the web application firewall that's already there, how do you know if it's being effective or not? And since PCI DSS 6.6 says that although they recommend both a web application firewall assessment or a web application firewall and the code analysis, but they said that they don't require it. So I'm just wondering, how in the world does it know that the scanner's finding this stuff, and how does it know that the web application firewall is effective if it's claiming to be?
So once again, it's striking that balance between manual assessments and automated assessments, and also automated scanners such as the WAF. This sort of is the crux of our whole entire industry. You're not going to be able to find every single vulnerability within your environment. And there's always going to be ones that aren't going to be discovered yet. There's always going to be ones that maybe you just missed when you're doing your assessments. So this very much the nature of our whole entire industry. And just like any traditional firewall, there's ways of getting around firewalls. There's ways of encoding traffic. There's ways of spoofing traffic. So that way you trick the firewall into allowing you to get in. And same thing happens with web application firewalls. And once again, it's always about using some sort of layered approach. Especially, using some sort of, especially from the guidance of, the Success 6 supplement. You have to use some sort of layered approach from penetration testing, vulnerability assessments, and that's what PCI requires. So, once again.
Now, this next one is my favorite, okay? Because we're also an ASV, which is an approved scanning vendor, okay? So what happens when you're an ASV is once a year, the PCI Council is like, all right, we're going to set up this test environment for you, and you have to scan the test environment, and if you find a certain number of vulnerabilities, and if you do give correct reporting, and if you do all this stuff, you're an approved scanning vendor, okay? There is nothing in place for these web application firewalls or scanners to be certified as an approved an approved web application scanner for PCI 6.6, DSS 6.6, or the same thing with the web application firewall. So what? So I download a free web application firewall and throw it in front of my web application, and and then that's acceptable. And if I have a Barracuda, that's acceptable, and if I have ProFence, that's acceptable. Like any web application firewall is acceptable, and any scanner is acceptable. I mean, there's no certification process in place for these. So what I would propose, I think, would at least be better and would at least make me sleep a little bit better at night, would be if maybe the web application firewall guys, okay, perhaps what happens is they say, hey, I want to be considered for certification from PCI, for certification. Then what PCI does is they say, okay, what are the configurations in this web application firewall that need to be configured in order for your proposed PCI compliance guidelines? And then they could say, all right, configure the web application firewall this way. All right, then what happens is PCI takes the web application firewall and tests it. They have a vulnerable environment that they know where all the vulnerabilities are. They put the web application firewall in front of it, and then they try to exploit the vulnerabilities using a whole bunch of different techniques. And depending on how well the web application firewall is able to protect the system, then it's either approved or it's denied. Same thing with the scanner. Yes? Yes. Oh, well then what it would have to be is it would say for 2011 in PERVA, just like now for the ASV scanning, Secure State right now for 2012 is an approved scanning vendor. You have a list of the approved scanning vendors, just like you should have a list of web application firewalls, just like you should have a list of web application scanners. And then what happens is those have to go through some sort of certification process. And suppose in 2011, in PERVA, they fail, okay, or they're scanned. Well, then it's no longer acceptable. It's no longer approved. And so you'd have to change your product at that point. Well, I mean, then that's the organization. I mean, the organization shouldn't have signed a 3-year contract with them then. What I'm looking at is I'm saying I'm worried about my information being protected, and it's not fair that my information is in danger because these organizations don't have to have some sort of standard that they have to comply to. Perhaps what you do is you say, okay, Imperva, you failed. You've got 3 months to get your act together, because Imperva is not going to want to lose all that business. They have 3 months maybe to get their act together, and I can see the PCI Council working with them a little bit. And if Imperva is not willing to clean up their act a little bit, then it's probably not good for organizations to be using the firewall, and they should probably drop out of the industry at that point, which is probably what would take place. But that happens all the time, right? I mean, we have software that eventually becomes obsolete, and Imperva at that point would just become obsolete. Yeah, and exactly. And the thing is I mean, if there maybe there's also a grace time frame for the person who has Imperva, that's using Imperva, that they have a grace period to change their product or something like that. But I just don't think that we should be using any single web application firewall or scanner and saying, hey, you get your checkbox just because you scanned or have a web application firewall in place. I just disagree with that.
But also to Gary's point and your point as well, I've actually have done some assessments where an ASV scanning vendor, not us, they were in transition, and it basically you have to do your ASV scans every quarter. And what ended up happening to one of the companies is they dropped one of their ASV scans where they couldn't do their scans because the ASV scanning vendor was in the process of getting their scans to go. And basically we had to talk with the actual card brands and also had to talk with some of the council. And basically their response to the client was, you should have went with someone else to get your second quarter scan. So it's kind of sometimes PCI can be a little tough on certain things that sometimes make sense, and sometimes they can be tough on things that just doesn't quite make sense. So once again, I mean, you can't make a new scan from history. So they basically the end of the story is that they eventually let them pass, but it took them a little bit extra time for them to pass because they didn't have their passing scan for one of the quarters. So I actually kind of agree with some of the things with this, but once again, there are some definite considerations when you start getting into service level agreements with organizations and with different vendors. I think definitely, especially since some of these are signature based, that could also be an issue too from doing some sort of validation, where you're compliant for a period of time and then you update all these signatures for your web application scanner or your WAF. Now, if that might not actually pick up some of the things that it was supposed to pick up because you implemented that new signature. However, the other thing could be said about penetration testing and other types of assessments where PCI really hasn't had any type of standardization of penetration testing, etc. And that's one of the reasons why like P-Test was created, that creates some sort of standard of what's an acceptable penetration test, what's an acceptable code review, what's an acceptable static code review. And so those are some of the things that are probably good to consider from this type of process. But yeah, definitely, there are some issues when you are sort of when you have a contract or a long-term contract with some sort of device or a system or a scanner or what have you. A lot of times you have to sort of bite the bullet.
All right, so let's talk about some conclusions. Let's wrap it up now. So, in a nutshell, compliance does not equal security. We think that the council should require stricter web application scanning and web application firewall requirements. So there should be, I think, a little bit more clarification. And from my point of view, there should definitely be some sort of approval process or a certification process in place for these controls.
So another thing that I identified too is better development life cycles, baking security into your software development life cycle. Actually, Kevin Johnson gave a presentation at one of the OWASP meetings, the Cleveland OWASP chapter meetings, and that's essentially it, where you bake security into your processes, where you're doing vulnerability assessments and code reviews before it gets implemented into production, which actually you're supposed to be doing anyways per PCI. So doing those, getting those quick and dirty vulnerabilities identified that scanners can pick up, that other things can pick up, and then probably a little bit later on down your development cycle, have someone actually beat the snot out of it from a manual standpoint. So that way you're sort of striking that balance of manual versus automated, catching the low-hanging fruit, and then sort of working your way up to catch some of the stuff that's not so low-hanging. And then that way, when you have an attacker try to go against your web application, it's a little bit more secure than it was before.
And then finally, a layered approach to security. So the council, if you want to be secure, if you want to be compliant, or just compliant, then either do one of the other, web application firewall or a scan or some sort of manual assessment or something like that. If you're just looking for a checkbox, then do that. Go ahead. But if you want to be secure, it requires a layered approach to security. There should be a web application firewall, a web application scan. You should also be doing real code real code reviews. I mean, actually having someone come in who knows what they're doing, do a source code review on the web application before it goes out into production. I definitely think that also manual gray box type of assessments where somebody goes in there who has credentials and attacks the web application manually, I think that should be done too. They're going to catch those logic type flaws. They're going to catch a lot of those delayed cross-site scriptings or the cross-site scriptings where you have to do everything just right in order to get it to execute. There should definitely be a manual component to these reviews. So, I mean, you can't just rely on one product or one process to protect you. You have to have a layered approach.
And there's some of our references, basically a lot of the PCI Council documentation, and also Kevin Johnson's presentation on developing application security testing within your SDLC. So, any questions?
Yeah.
Yep. Right. Right. So I guess the biggest thing from that standpoint, we did break into these things using the default configurations from a WAF standpoint, and then also, you're basically saying that it does take some configuration to do it, and that's right. If you configure it right, the environment, you will be able to probably protect yourself from a lot of vulnerabilities.
But then in all fairness then too, if you're really trying to protect your environment and you're the PCI Council and you're trying to, because remember, this is not every web application that has to have this in front of it. It's every web application that stores, processes, or transmit cardholder data. And I definitely, and if it's not segmented from the rest of the network, then all of those definitely fall in the scope, I believe.
Yep.
But definitely, I mean, you're talking about a very sensitive web application here. And I mean, there needs to be a little bit stricter guidance, I think. So if you're PCI and you say, hey, don't use a default configuration, you need to be whitelisting, and this is why.
And also marketing, too, is another issue as well.
And then in the back?
Yep.
Yep. Now, what I would say is, that's why I think that certification process is so important. So don't leave it up to the QSA to go in there and go, oh, look, you're protected from everything because you have the default configuration in place. Because then it's an incentive for the QSA to lie, essentially. Or I don't want to go there, but to get a crummy QSA then so that they pass it. But if you had that certification process, then you have somebody, a third party, evaluate the web application firewall or the scanner and see how well it actually is performing the job that it's supposed to. And then the QSA has no choice. It's like, okay, do you have an approved web application firewall with an approved configuration, yes or no? And then the same thing with the scanner. Because if not, you could just use
Also, another thing is, too, from like payment applications that are PCI DSS compliant, an actual, someone that's not only a QSA, they're also a PA QSA. They actually have to perform that assessment on those type of applications. And so when they actually perform that assessment, they then have to also submit that application to the council for them to review it as well. So there's incentive for the PA QSA to find the vulnerabilities, and also incentive for the company or the third party to actually get that stuff up to snuff. So it's sort of outside the QSA's realm of validating those type of third-party things, because basically, me as a QSA, I would say, is it whatever validated? Is it PA DSS compliant, or is it a WAF that's compliant to PCI? I would see that, look at the implementation guide, say, yep, it is, and then we're done. So it's kind of outside like the QSA, but definitely right. If you have someone that's not as well qualified, you're going to have those types of issues sometimes. Yep. Well, that's sort of talking different layers of the OSI model. So these web application firewalls are working on the higher levels, so like around the 7th layer, where if you segment things like that, which is actually part of PCI, you're supposed to segment your systems away from each other from the network layer, so the network layer down. So that does help, but once again, the application would still be vulnerable. Yep.
Now, more importantly, though, that helps you go over updates to that yet. At that point, obviously they're not going to be expensive lobbies. PCI helps actually put all this stuff you guys have in the time that we actually have change that makes sense other than just whatever the cost.
Well, actually, the council does have some time frames. Actually, I think we're just around that time frame of making suggestions for the next standard. So QSAs and also merchants do have the ability to put in suggestions to help improve PCI. So right now, the way that it works is it's on a 3-year cycle, where right now it's in the review cycle, and next year they'll make the updated version of PCI. And so essentially the first year, everybody sort of has like a little bit of a grace period where they can either use the older standard or the new standard. And then essentially then it gets used for that year. The second year it then goes into review, and then after the third year, after it's gone through review and everybody has made whatever changes they want, then it gets released sort of like in that 4th year, and then the cycle continues. It used to be on a 2-year period, which they sort of decided which was too painful for a lot of the merchants to be on a 2-year cycle. I imagine, I don't know if there is, but I imagine if you go on the website, they have contact information, so you can always write to them. As far as whether or not they actually get it, I don't know.
All right. Well,
yep.
Go ahead.
So once again, each QSA is going to be a little different. I would say maybe and also there could be risk-based issues. So, my opinion, that would be probably nitpicking. Maybe if you have life support systems that need to be, that work on that time system, and if it's not that precise, then things can go wrong. Maybe you should look at it that in depth. But outside of from PCI standpoint, I don't think so. I mean, there's also a whole in-depth thing of how many nanoseconds you're going to be off depending on what type of category of NTP you're syncing to your originating time system. So it can be minutes off, seconds off, nanoseconds off, or even half nanoseconds. I mean, as long as your systems all coordinate together and they actually, when someone does forensics, they can actually tie all these different systems and be able to figure out when someone hacks something, if, gosh forbid, you got breached. That's pretty much what you need to find out. That's the intent of the NTP, is to make sure that all the timestamps are the same on all the systems. Oh, okay. Makes sense. Well, I mean, yeah, from this timestamps issue, it's more along the lines of a forensics. That's why they have timestamps in there. It's so that way, when you submit this stuff to to court, so to speak, you can actually prove that this happened at this time during this, and they actually did do this, and it did originate from this. And so that's what they're trying to prove with timestamps.
All right, and I think we're just about out of time, so I just want to thank everybody for coming out here today and listening to our talk. And if you have any questions, or you could always come up to one of us or ask us or something like that afterwards.
Yep.
All right. Well, thank you.